Hey everybody, it's Mr. Wolf. We're back with another video for Unit 6, and I want to start off this video by clarifying a mistake that I made in the first Unit 6 video. And this mistake involved circumference. Maybe some of you caught it, maybe some of you saw the announcement I made, and I apologize for making this mistake, but let's hopefully clear the air here and make everything back to the way it should be and the definitions that you should know. So the circumference, we say, is the distance around a circle. So one way to think of this is if we made a little slice, let's say we made a slice there in this circle, and we stretched it out, flattened it out, and then got the measure of this line, then whatever that measure is would be the circumference. But of course, that's the difficult way of doing things, because you can't necessarily slice this circle and drag it out. So how do we get the circumference? Well, I used a formula that was actually for the area of a circle in the last video. So what is the formula we use? The formula we use is C, the circumference, is equal to 2 times the radius of the circle times pi. Or we could say that it is equal to the diameter times pi. And you may be asking, well, how can you use these two different formulas to get the same thing? Well, let's think back to what radius and diameter mean. A radius would be the line segment from the center point of the circle to any point on the circle. So, for example, this line here, we'll say it goes from A to C. That would be the radius. And then we said the diameter is the line that goes from one point on the circle to another point on the circle and goes through the center point. So let's say we have this, with C being our center point, and we'll say this is B over here. Line segment AB would be our diameter. And then line segment AC or line segment BC would equal our radius, because our radius is half of that. So looking at this, we know that radius is equal to the diameter divided by 2, or the diameter is equal to 2 times the radius. So when you come back over here, we can see that this 2 times the radius is the same as the diameter. Now let's do a short little example here. Let's say that we have a circle with a radius of 4 inches, and we want to get the circumference. Well, we would say that C, our circumference, is equal to 2 times the radius, which is 4, times pi. Or using that other formula, we know that 2 times the radius is the diameter, so 8, our diameter, times pi, would also equal our circumference. And in this case, you can multiply this out, or you can just stick those together, and you're going to get the same answer, and that answer is 8 pi. Now, when it comes to these, I mentioned this in the last video a bit, but you can leave it at this. You can leave your answer just like this. You don't have to put the pi in. You don't have to get the decimal, because in the end, this will be the most accurate answer because it's not rounded in any way. When you multiply these out, get a decimal, and round it, you lose a bit of accuracy in your answer because you have to round that. If I want to see if the decimal's right, I can multiply this together and check. But when you get to this point, if you want to leave it at this step, that is completely fine. Now let's move on to something related to circumference, but not necessarily the full thing. Let's go ahead and look at arcs. So what do you think an arc is? It's actually a pretty descriptive word. Like when you think circumference, you think, well, that could mean anything. But when you think arc, okay, well, that has some real world meanings that could kind of lead you to the definition. So the way we define arc is the arc of a circle, or an arc of a circle, is a piece of the circumference. A piece of the circumference. So what exactly does that mean? Well, let's look at these images we have here at the bottom. We have a picture of Pac-Man, pizza, and a Ferris wheel. Well, if you look, there's this angle here created by Pac-Man's mouth. that separates this circle into two parts. We have this section here, then we have this larger section here. And these sections of the circle that are broke off by these angles, or these points here, are called arcs. Pizza would have one here as the crust of the slice, and then the rest of the crust of the pizza creates these segments like things, these portions of the actual circumference of the circle. The way I like to think about it is we've worked with lines and line segments a lot in the past. We said if we had a line that it will go forever in both directions. But if we have a line segment, it's just a piece of that line, just a small piece of that line. So think of an arc as a piece of a circle's circumference, similar to how a line segment is a piece of a line. There's some more important facts here that would be good to know. That every point, and we covered this a little bit in the last one, every point on a circle is equidistant, or equal distance from the center. So every one of these points along the outside of a circle is of equal distance from that center point. So if we were to take an arc, per se, that we're building an arc out of two radiuses. So that's one way to think about it. You got two radiuses that create an angle. That could be an arc. But then you think, well, what happens if I make this arc so big that, let's say, these two line segments are right on top of each other and they encompass the whole circle? Well, that's really just truly the definition of what a circle is. An arc with a measure of 360 degrees would be the entire circle, or the circumference of the circle. Let's break down arcs a little bit further into arc, more of a just facts about arcs and how you would notate them. So, before we do this, let's discuss an integral part of the arc, and that is central angles. So, let's have a circle here. And this angle that creates the arc is what we call a central angle. So a central angle is an angle whose vertex lies on the center point of a circle and the two other points will lie on the circle. Now, this is a long definition, but I think it gets the point across rather well. So the central angle of any circle is going to be an angle where you got a point right in the center. That's going to be the vertex. And then no matter how many lines you create off this, we can say that we'll call this one A, this one B, this one C, this one D. We can say that, well, one central angle of this circle could be, we'll call the center point X, could be DXC. One central angle could be BXC. Another one could be AXB. And I think you're getting the point here. So any angle that has line segments that hit the outside, or the not outside, but on the circle, and meet at that center point vertex would be a central angle. And those help us notate an arc. So let's look here. Let's say that this is C, our center point. Well, this point A, and this point B. We want to notate this arc. You may think, well, okay, We have central angle BCA, but we want just this portion here, just this arc. And encompassing within this angle here, is that arc. So we look to what the point lies within that circle, where that arc is, and it's as simple as drawing this little symbol here and your A and B under it. So notating an arc is as simple as the things we've notated before, where, with a line segment, if we had line segment AB, it'd be AB with a line. If it was ray AB, it'd be AB with a ray over top of it. If it was circle, you'd name it circle with the center point. These kind of pattern where you draw a symbol that means what you're talking about, and then the points involving it. So in this case, if you wanted to name an arc, like this arc AB, you would just write AB with an arc over top of it. So that's how we notate it. But let's think about the measure of an arc. How could we get the measure, the actual measure of this line, this AB arc? We're going to measure this in degrees, because if you look, it's just an angle. We often draw these little symbols here to notate angles. That's really what this arc is here. So if the central angle, let's say this central angle equals, let's say 80 degrees. If that central angle is equal to 80 degrees, the arc it creates is also equal to 80 degrees. So in this case, arc AB would equal 80 degrees. And it's as simple as that. This arc here, created by central angle BCA, is 80 degrees because BCA equals 80 degrees. So, central angle measure is equal to arc measure. And there's one other thing you may be asking yourself here that could be kind of confusing. And that is, well, we do have this little line segment here, this AB. That's an angle, but here on the outside, this is a big angle, but this is also an angle out here. And that's a poorly drawn angle symbol, but we'll try to redo it here a little bit. So this is an angle out here on the opposite side of C. So what is the difference in these two arcs? Because this little piece here is an arc, but also this gigantic portion around here would also be an arc. And that's where we get to differentiate between the phrases minor arc versus major arc. What we were looking at here, this AB portion, is what we would call the minor arc. The minor arc lies between two sides of a central angle and is always going to be less than 180 degrees. So let's go ahead and write that. So the minor arc lies within the central angle and is always less than 180 degrees. So that is minor arc. Minor arc lies within the central angle and is always less than 180 degrees. But what about major arc? How would we define major arc? If major arc is this other piece, we can kind of form a definition just from what we wrote here. We could say that the major arc lies outside the central angle and is always greater than 180 degrees. That is the major arc. So back to this picture, and we'll erase some of this stuff around it and to give a more clear example of what we're talking about. So if we had central point or center point C and these points A and B, The arc A and B, this, as we notate it, A, B, would be our minor arc. Is the minor arc. And when it comes to notating major arcs, you're going to have a point here extra, kind of on the other side. So we'll throw D down there. So arc BDA is the major arc. So we notate the major arc and minor arc very similarly. You just kind of say where this section of the circumference is going through. So AB goes through A and B and stays between those. And then BDA, or you could say ADB, goes from point A through point D to point B. And that's how we label our minor and major arcs. So we talked about how you find the measure of a minor arc, or the center. It all revolves around that central angle, right? So if we said earlier, if this was 80 degrees, then this arc measure is 80 degrees. Well, then what's the case for the major arc? If we know the minor arc, can we get the major arc? The answer to that is yes. Let me get this erased here. So if we know that our minor arc equals 80 degrees, how would we find the measure of ADB? So if AB here, this AB arc equals 80, ADB equals what? Let's think about this. The whole circle, the entire circle, we've talked about this before, encompasses 360 degrees. So if the whole circle is 360 degrees, then we know that these two arcs added together, AB plus arc ADB, will equal 360 degrees. And would you look at that, we have AB. We can plug in this 80 degrees for it. 80 degrees we have up here. So we know that 80 degrees plus whatever the measure of ADB is will equal 360. Well, then from here, it's simple. We subtract 80 from both sides, and that gets us our answer. ADB is equal to 280 degrees. I hope that makes sense. So let's review this again. I'll create a new slide here. So an arc is a piece of the circumference. We have the central angle that creates an arc, and it is made up of an angle whose vertex, we'll just write angle, vertex at center point. So we think back to what we've been looking at. An angle such as here, where the center point is its vertex and it has two other points that are on the circle somewhere. That would be a central angle. And then we have the definitions of minor arc. Minor arc is within the central angle and less than 180 degrees. And then we have major arc, which is kind of the opposite of that it is outside the central angle and more than 180 degrees. Now let's write arc under this. Major arc is outside the central angle and more than 180 degrees. We notate minor arc by the 2 points that create it. So we used A and B as an example earlier. And then for the major arc, we use the same 2 points, but the point that lies between them, which in the case we used before was D. So something like this, ADB. And then we say that the minor arc measure is the same as the central angle measure. And then the major arc measure is really just what's left. So to find the minor arc, or the arc made by the central angle, you find the measure of the central angle. To find the measure of the major arc, you have what's left. So 360 degrees minus the measure of the minor arc equals the major arc. This stuff's a bit different from what you guys have looked at before, but I hope this comes as somewhat simple to you guys. I know this is kind of a tough concept because you're not used to working with circles. So I'm hoping to ease you guys into this a bit. If you guys have any questions, feel free to reach out to me or Mr. Rose. If you need help with the worksheet that's going to be following this or the note sheet or anything, please reach out. But make sure you guys are trying your hardest to watch these videos from front to back, from beginning to end, pausing where you need to take note, and doing your best. You guys are doing great, staying caught up this far. Let's keep doing that throughout the unit and we can have some fun. Thank you guys for watching this far into the video, for those of you who are. If you are watching this far into the video, let me know somehow. You can leave a private comment. You can write, "I watched this far," down in the bottom of your note sheet. Just let me know, and maybe you'll get some bonus points for it. Anyway, guys, I'll leave it at that. Thank you guys, and let's continue to think about circles.